Hi everybody, my name is Vasco and I've been working on this no estimates thingy since 2012. Now it seems to be a big thing, but it's actually a pretty old thing. I started using the ideas that I'm now talking about. I started using those back in 2008 in a big project that nobody knew how to estimate. And why they didn't know how to estimate, it's very simple to explain, because there were about 500 people, 100 teams or so, working in an agile setting. Now, obviously, it's easy to get 5 developers into a room to plan, using planning poker or whatever, but try getting 100 teams to agree on the estimation method. It's not going to work. And now try to get a representative of each of those 100 teams into the same room to play planning poker. That's not going to work either, because some teams were in India, others were in Australia, others were in California, others were in Europe. It's not going to work. So how do you estimate a project that has 100 teams, 500 people distributed all over the world? The answer is you don't. You don't even try. That's just the stupidest idea ever in the universe, right? But you still need to know when it's going to get done. So what could you do? And that's what we will explore today. But before we go there, I would like you guys to pair up and answer one question. Just discuss between you. And at the same time, before you actually start the discussion, can you take that, put it just there in the middle so that people can fetch it without having to come all the way to the table, because that might be intimidating. Right, so what are estimates in one word? So pair up, discuss, agree, write it in English, please, because I will not be able to understand it if you write it in Polish. Write it on a post-it over there. You have markers and post-its. What are estimates in one word? And then when you're done, you can just come and put it here. So let's do this in 5 minutes. Is that okay? Everybody okay with that? All right, go for it. Let's quickly look at the answers we got here. First of all, let me say that a lot of people wrote, well, not a lot of people, but we have 6 instances of forecasting. So just to be clear, the weatherman does not sit down and ask the other weather people to put up a poker card. That is not a forecast, right? Putting a poker card up, a planning poker card up, is not a forecast. Saying that an estimate is a forecast is fundamentally misunderstanding the role of forecasting. Estimation, if you go by the English definition, includes everything, right? It includes everything. If you say that I might be sick tomorrow, that's an estimate. If you say that this store is a 5, that's an estimate. If you say that I think we need a new version control system, that's an estimate. So estimation in general as a word is useless. It doesn't help you to understand what people are referring to. So let me be very clear. When we talk about no estimates, we talk about not estimating cost or duration. It's okay to estimate value. Why is it okay to estimate value? Because if you fail, you lose. The unfortunate truth about estimating cost or duration is that you fail and you still win. So an estimate in terms of cost or duration makes absolutely no difference to winning or losing, except that it mostly causes us to underestimate the real duration, and we'll talk about that in a second. So I wanted to make that very clear, because a forecast is, according to the English language, an estimate, but it is fundamentally different from estimation. For example, that 500 people, 100 team project that I was talking about, we did forecasts all the time, but we didn't get 100 people together in a room to put up poker cards. Fundamentally different things. So when you talk about estimates, make that difference clear, right? Because otherwise we don't know what we're talking about. Okay, but then we go with guess. A lot of people put guess, and some wise person even put 2 words as one word, fortune telling. That's great. But I wanted to ask, what does chain mean? Because I did not understand that. There's 2 people.
You estimate and anybody hear that, you're like having your hands chained because you have to fulfill the expectation.
Yeah, so it's actually a promise and a deadline.
Yes.
All right. So these are some of the things that we definitely don't want estimates to be. We don't want them to be promises. We don't want them to be deadlines. But here's the unfortunate truth. Every time you estimate, the other person hears a promise and a deadline. It's not up to you. That's out of your power. You have no influence on what others feel. So there's a lot of smart people saying that, well, but you know, estimates are not promises. They're not deadlines. You're misusing estimates. And I go like, yeah, but you don't get to decide that, right? So some people say, hey, you shouldn't throw the tool away. Estimation is useful, even if the estimates can cause problems. All right, that's true, but waterfall was also useful, even though it could cause problems. Did we stop? No, we threw waterfall away. So why are we rethinking the tool implies behavior problem that we did with waterfall and not applying to estimation? Because let's be clear, whether you like it or not, when you estimate, you start a chain of events. A promise, a deadline, a selection of technology, narrowing down into one solution way too early. Estimates lead to premature optimization, for example, right? Because we want to get it done. Doesn't matter how, because we promised it, right? And then there's the other part that comes with this. A lot of people put here blame, suffering, lack of trust, lack of safety, lies, pain. All of this come with estimates. Do you want this? No. Do you blame the weatherman when it rains?
In Poland, yes.
Well, so you.
That's our thing.
I think Marvel must have modeled their superheroes out of Polish weathermen then, because, you know, influencing the weather, that's kind of superpower. But we don't, right? Because, you know, we know for a fact that weathermen are not always right. So when we look at the weather forecast, we take that as input, not as a promise. That's an important distinction. We don't ask weather people to estimate the weather. We ask them to forecast the weather. It's a huge difference in that. And the difference affects how we relate to each other. Because if I give you a statistical model that tells you, you know, if we have this many stories, this is when we're going to land, i.e. deliver. If we have this other many stories, this is the next delivery date, then the people can play with that model. They can tweak it. They can change the number of stories. They can look at, okay, if we want to release on date X, what is the maximum number of stories? And then they can actually act on it. They can go to the backlog and remove the extra stories. But they don't take it as a promise. They don't take it as a deadline. Because it's a bloody Excel spreadsheet. It's not a person making a promise. Right? So there's a huge difference between using models for forecasting and estimating. And that difference has a direct impact on how you feel about your work. Because no one feels happy about missing a deadline. But everybody understands that if a model says you're going to deliver 10 stories and you end up delivering 8 stories, that's perfectly fine. Models have errors. We all accept that. Just like the weatherman. When they say it's going to rain and it doesn't rain, the agriculture people are sad, perhaps even furious. But the rest of the people are happy. We can go out and have some drinks outside. Great, right? So that's where we want to go with no estimates. We want to go to a point where the deadlines, the forecasting of the date when we deliver is not a personal commitment. The worst possible idea Scrum has ever introduced in the world of Agile after the not having retrospectives, because, you know, those of you that have done Scrum long enough remember that the original Scrum did not have retrospectives. Now, that's a stupid idea. But anyway, after the no retrospectives idea, the worst possible idea Scrum has ever introduced is commitment. Commitment is what Deming used to call tampering. What is tampering? You have no clue why we delivered 5 stories, but we're going to punish the people anyway. That's a stupid idea. Because it might be that the reason we delivered 5 stories instead of 10 stories was because the continuous integration, version control system was down. We used TFS, it's a centralized version control system. It was down. We couldn't work for 3 days. That's why we delivered only 5 stories out of 10. But nobody asks that because you missed the deadline, right? That's where the blame thing comes from. Now, other people said planning. Planning is great. It's so great, in fact, that you should do it so often that it doesn't matter if you use estimates or not. We should be planning all the time. We, in fact, should be replanning all the time because every day we discover something new. When we do plans based on estimates, imagine planning a project with 500 people for 6 months. That must have been a huge work breakdown structure. And there are companies doing that. Now, play this mind game for a second. How many people do you need working with Excel or MS Project to plan 6 months of work for 500 people?
One person.
For how long? One person for infinite number of days, or an infinite number of people for 1 day, right? But a lot of people, a lot of time. Well, guess what? If you use a forecasting model, you can forecast 100 times per second, you know, as fast as Excel goes. It doesn't matter. You can do a Monte Carlo simulation that does whatever, 100 generations of that project with multiple distributions, with different dependencies, all of that, hundreds of times per second. Isn't that a much better choice? Why would we use intelligent people to go down to the task level and plan work for 500 people 6 months? That's a stupid idea. But guess what? That's how we work in many companies today. Now, of course, planning 5 people's work for 6 months is a lot easier, but it's still a stupid idea. And we know that because priorities change. People get sick, machines break down, emergencies happen. And what do you do then? You replan, right? I really like the plan idea because actually, in no estimates, what we are trying to do is making planning so cheap you can do it several times a day instead of once at the beginning of the project. There's an example in the talk, if we get to that, of a company that is doing that right now. All right, well, thank you very much for playing the game. This is going to get even more interesting from now on. By the way, it's the end of the day, right? Everybody's tired. No matter how interesting the topic might be, it's better to make it interactive. So if you have questions, just raise your hand and let's go through the questions. We don't need to go through the slides because it's on YouTube anyway, right? You can see this talk 100 different times. Right, so we're going to talk about 10, actually 11 principles. So today you get one for free, the 11th principle. But first, this is based, all of this talk, and actually a lot of my knowledge is in the book. If you go to this URL, you actually get 3 books. So there's the No Estimates book. There's also a guide of applied capacity planning using no estimates, and contracts with no estimates. How do you do contracts with no estimates? So you can go there and you can download the book. Right, but think about this. If you go outside and you interact with the real world, you're not going to use estimates a lot. I mean, you're going to use some estimates, right? You're going to estimate, can I cross the street faster than that car can reach the crosswalk, right? You're going to estimate things like that. But you would never estimate, at least you wouldn't bet your house on an estimate of a football game, right? This is Iceland kicking Portugal's ass in the first game of the Euro Cup. Portugal, by the way, won the Euro Cup without ever winning a game in 90 minutes. Think about that. Who could have predicted that? But it happened. Right, and over there, there's Pepe throwing his hands in the air and say, oh my God, did we just lose the Euro Cup because we came here to win? But in the end, they won. And guess what? That was also a surprise. Nobody thought they would win. France was clearly a much better team. How did that happen? It doesn't matter. We know enough about football never to bet our house in the result of a football match, right? Would you do that? And the reason why you wouldn't do that is because there's enough uncertainty in a football match for you to understand that it's not wise to bet a lot of money on a football match. But actually, software projects suffer from the same kind of uncertainty. I mean, think about it for a second. Let's say you have a relatively small project, 10 people. Relatively small time, 3 months. 10 people, 3 months. How many surprises you think can happen to 10 different people in 3 months? I'm sure somebody with more math chops than me would come up with a probability distribution of, you know, the number of possible surprises. Let's just say a lot of them, right? And the more surprises can happen, the more likely it is that one of those surprises will have a huge impact. Like, for example, TFS goes down, and we use TFS, therefore, when TFS is down, nobody can work. That's a huge surprise. It has a huge impact. Can it happen during 3 months? Well, if you know TFS, you know it can happen every 3 hours, so that's okay. It's relatively safe to bet that will happen. But when will it happen? That's different. We don't know, right? That's a surprise. But yet, we are betting significant amounts of money in projects. How do we do betting in projects? We try to plan in the beginning of the project. That is a bet. Every single plan is a bet. How can you win at software projects? It's easy. Agile people have been doing this for years. You replan every day. You change the priority in the backlog. You remove stuff. You reduce the scope of existing stories. You make agreements with the customer. You release often. There's plenty of strategies to make sure you win at software projects. But get this, estimation is not one of them. Getting better at estimates does not mean you get better at succeeding with your software projects. And we'll talk about that. I'll give you a few examples of that. But first, even if you think you could succeed by getting better at estimates, let me just say that a lot of people have tried that before and they failed. So unless you think you're a Polish weatherman that can change the weather and has superpowers, then don't try that. Because there's a lot of smart people out there trying to be better at estimates, and they are failing. So why should we do that? So no estimates is actually alive and kicking elsewhere, and accepted also. We accept that that football games have a large uncertainty. We don't bet a lot of money into that. So what are the principles we can take out of this? Well, let me just start by saying that we do have 11 principles. So this one goes all the way up to 11. But no estimates is only for you if. So if you're not in these categories here, then it's probably not for you. So the first one is you're bored with estimates. It's like, again? Didn't we just do this 2 weeks ago? Like, why do we need to do this again? Or my favorite, why do we need to re-estimate all of the items in the backlog? There are teams out there doing this. I don't know if any of you is doing that, but there are teams out there re-estimating backlog items. Just insanity. No estimates is also useful if this is how you feel when you ask for an estimate. Some people obviously feel that way, right? No trust, not safe, it's like a promise, it's a pain, it's a blame game. Yeah, and estimates can really blow in your face. I've been there. I know they can. And finally, no estimates is for you if you want to focus on this. Happy customer, happy team. Because getting better at estimates does not guarantee happy customer, and it certainly doesn't guarantee a happy team either. I mean, just look at TFS. If it goes down, we're all unhappy again, right? So this is a train. How many of you know what train this is? The Shinkansen. Yeah, it's good to be in a geek audience. Everybody knows the duck face or bullet train. Okay, so I don't know how the trains work here in Poland.
Not like that.
But in Japan, this train had an average delay of 54 seconds in 2014. And the fact that they measure delay in seconds should already tell you something about this train, right? It's like, oh my God, in seconds? Last time I was on a train, I was 1 hour late. Okay, good, 54 seconds. But here's the thing, when you enter this train, you can be pretty sure it's going to be on time. You don't need to go to your meeting the day before because you know you can take the train. If it takes 3 hours, you take a train that leaves 4 hours in advance of your meeting. You get to Tokyo, you still have time to visit that manga shop you wanted to visit and then go to the client. It's easy. It feels relaxed. It's calm. Now, I'm from Finland. And in Finland, trains basically only have 4 problems. So they have winter, because the ground is frozen, so the trains can't go that fast. Then they have spring, because the ground is not frozen anymore, so the trains can't go that fast. And then there's summer. It's too hot. The trains can't go that fast. And then fall. When there's fall, there's leaves on the tracks, and then they have to go slowly because it takes longer to brake. But other than that, they're perfect. So if I have a meeting in Tampere, which is 2 hours away from Helsinki by train, and I need to meet a customer, let's say at 2 p.m., I'm definitely not going to take the 12 o'clock train. I'm not going to take the 11 o'clock train. I'm going to be in the train station at 6 a.m. to catch the 6:30 train, just to make sure that if the train breaks down, I have time to walk out of the train and walk to the nearest village to get a taxi. Because it can happen. Right? When I'm in a Finnish train, I'm nervous. Am I going to make it on time? Is the train going to break down? Is it going to be too hot and I'll be all sweaty and smelly when I get to the meeting? It can happen. All of those things can happen in Finland. So I'm going to be nervous. I'm going to be stressed out. And if I'm smart enough, I'll drive. If I'm not smart enough, I'll take the train the day before and spend a few more euros and stay at a hotel just to make sure I'm, washed up and clean at the meeting on time. Which of these cases sounds more like your projects? I know about the smelly rooms. It's fine. We're all developers.
It's a tricky question.
It's not a trick question. It really is an honest question. Because until your projects feel like being on a Shinkansen, you have to change stuff. That's principle number 1, is you either trust your process or you change your process. In Agile, we have this great idea of continuous improvement. That's brilliant. It does not work with processes that are related to estimation, because estimation is fundamentally broken. So if you have to be predictable, reliable, just like the Shinkansen, you have to do the same that the Shinkansen did. What did the Shinkansen team do? They built a completely new rail track. They removed all of the crossings so that the train track would never cross roads or be crossed by animals. They made the train faster than it needs to be so that if they are late, they can catch up. They did not allow 2 trains to be on the same track in opposite directions. That's, by the way, quite scary if it happens. So you don't want that. So you have train tracks in each direction. There's one train going north and one train going south, and they never cross the same track. That's smart. Why is it smart? Because it removes the original problems that cause delays. It removes root causes of delays. Instead of trying to be better at estimating the potential delays and then updating the schedules accordingly, they just said, let's remove the causes of delays. Let's rebuild the train tracks from scratch. And that's what we talk about in No Estimates. If you want to be on time, forget about estimation. It's never going to work, and we'll see some data on that. So focus on doing something totally different, like No Estimates. Smart, huh? All right, so here's the story. This is an actual project. I was in this project. And you see here this blue line, very interesting, looks like a mountain. That's the number of bugs open. Right? Now imagine this. We're here. We're developing. We finished development. We're feature complete. Yay! Wait, what happened? Well, now we start testing. We find even more bugs. And we're here. At this point, imagine that you are in this team, you just saw this line go up, 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 and you are at this point just before the inflection here. When is this project going to be delivered? Never, not at all, have no clue. Where is my crystal ball? All right, and the obvious answer is I have no clue, maybe never. And then suddenly there's this huge drop in number of open defects. But of course there's no magic. We're not superhumans, we're not Polish weathermen. So what happens? We just went to Jira and clicked, won't fix, won't fix, won't fix, won't fix. That's a very fast way of getting rid of bugs, by the way. So obviously we see a huge drop, and then we're happy with ourselves. Hey, great, we only have half the bugs, or nearly half the bugs we had just yesterday. Smart move, hey. Then we started testing again, or we continued testing, and guess what? Soon enough, the bug curve started to grow again. Is that a surprise? Can't be. The more you test, the more bugs you find. You know, it's one of those laws of life. The more you test, the more bugs you find. It doesn't matter how much you've tested. If you continue testing, you find more bugs. So at this point, the project did release, though. Can you guess why?
Pressure from outside.
Pressure from inside the company, but outside the team. Yes, correct. So what happened? At this point, the CEO came down and said, guys, either you release tomorrow or we'll cancel the project. And we release tomorrow, of course. You can't go against that guy, right? So tell me one thing. What is the value of estimates when the release date is more influenced by the mood of the CEO than the actual delivery of software? Yeah, but he could have told us, we will release that date, no matter what you have, because that's what happened.
Yeah, but usually the release date is based on the estimate first, right? Of course, it was wrong because there were some bugs.
So you notice this blue arrow here, that's development phase. You notice this red arrow here, some people call it testing, I call it desperately testing and fixing phase. You know what we found when we look at this? We found that this red phase here, when we looked at small projects, it was about 3 months. Then we looked at medium-sized projects, and that red phase there, it was about 90 days. And then we said, hey, but let's look at big projects. You know what we found? 12 weeks. We found that the desperately testing and fixing phase in this company was on average 3 months, no matter the size of the project. And that's data, that's not an estimate. So what does that tell us? Tell us that the patience of the CEO was about 3 months. From the moment you say, hey, we've done with the features, we're not adding any more features now, until the moment the CEO came down to our room was 3 months. It has nothing to do with the estimate, nothing at all. You could have estimated here the release or there the release, it wouldn't matter because the CEO wants the product out, or the product manager wants the product out, or the salesperson wants the product out. This is just one case where no matter how much effort you put into the estimate, it has no impact on the release date. Zero impact. It does have an impact on the size of this phase, but it does not have an impact on the size of this phase. So what does that mean? It means that in practice, in some cases, and of course this is not the case for all projects, especially not the ones that are doing continuous delivery, because they don't have the red phase here, but in practice, in most projects, external forces, a strong manager, a very assertive product manager, a completely out of his mind CEO, have a higher impact on the release date than any possible planning work you might do. Now, I'm willing to admit this is not the case for all of you, but for those of you for which this is the case, just ask them, when do you want it out? You asked me how long it takes, but that doesn't matter. So when do you want it out? And we'll do as much as we can until that date. That's it. If you have a waterfall project that looks like this, you know that 3 months before the deadline you have to start desperately testing and fixing. And that's it. And that's actually principle number 2. The reason why this happened is because we have a very long feedback cycle, right? If you go into daily delivery cycle, if you deliver every day, you will always be on time. It doesn't matter what the time is. If you deliver every 3 months, then you might not be on time. If you deliver every year, you're probably going to be a year late, right? So if we shorten the feedback loop, if we go from large release cycles to very short, quick release cycles, we will have a higher impact on being on time than any effort on planning and estimation. But of course, there's still a lot of people that say that, you know, estimates can be accurate. So let's investigate that claim. This talk by J.B. Rainsberger, which is still online, by the way, it was at ORDEV 2013. The talk is called 7 minutes and 23 seconds. And he delivers the talk in 7 minutes and 23 seconds, sharp. Why did he do that? Did he plan it in advance? Did he time everything and make sure that he would say the right word at the right time so that the talk would take exactly 7 minutes and 23 seconds? No. He had a post-it with a few bullet points. He made sure he could do those bullet points in less than 7 minutes, and then he just filled until the 7 minutes and 23 seconds. That was it. He set a budget for the talk, and he met the budget. It was not an estimate. It was a change of the content to meet an arbitrary deadline. By the way, this is what Agile is good for. This is why we have backlogs. This is why we have prioritization, so that we can meet any arbitrary deadline. Now, of course, there's something missing from that. You still need to do very quick and frequent releases, because if you're not doing that, it doesn't help to have a flexible backlog. So, but he did have a message in this talk. It wasn't just an example of no estimates. His message was that when you're thinking about estimation, the cost and duration of anything is a factor of 2 things. The essential complication. So if you're trying to put the Apollo 13 on the moon, that's tough, but it's possible. I mean, they can even come up with a CO2 filter from material that is hanging around in the spaceship, right? That's easy. However, if you're trying to calculate the tax rate for somebody in Germany, that might be a little bit more complicated, right? That's the essential complication of the problem we are trying to solve. And then the next is accidental complication, and JB calls this us not being very good at the work that we do, right? Everyone knows that when you're in a hurry, you take this shortcut box out onto the table, and then you open it, and then you start taking out, okay, we'll skip the code reviews. We will not do any unit tests. Let's not do the integration tests. I'll just commit even though I didn't compile it. And I'll just deploy to production immediately, right? That's the accidental complication. So what happens? We take shortcuts. We make the code base worse. Therefore, we increase the accidental complication. Now, many of you will know, especially if you worked on somebody else's code, right, that accidental complication can be huge. So let's say you start the project, and there's a user story, which is add this type of user to the database. And you go like, that's a 2-point story. Great. You put it into the backlog. You work on all of the other stories. 3 months later, that story comes up. It's still 2 points. You start working on it. And you go like, OK, let me check where we should add the user to the database. And you do a search in the code. And you find out that there's 27 different places where you add users to the database. And your 2-story point, add user to a database story, just turned into the refactoring project from hell. But it's still a 2-story, 2-point story. Accidental complication went up. The essential complication is still the same. It's still adding a user to the database. But in fact, in that specific source code that you're looking at, it's an impossible job. You have to refactor a lot before you can even start adding users to the database. So what does that mean? It means that the accidental complication can be orders of magnitude higher than the essential complication. And in practice, what that also tells you is that relative size estimation with the use of story points is useless, because you can't compare a 2-point story in the beginning of the project to a 2-point story in the end of the project. It's not the same. And actually, we have data. There's some discussion going on Twitter this week with people presenting distribution of stories and their duration. And some of those have shown that, for example, a 2-point story can take as long as an 8-point story. So there is actually very little correlation of actual duration with the size estimate in story points. So we can see this happening in practice. And there's another problem. You know, some people take their cues very, very seriously. That's just a quick hands-up question. Okay, in your backlog tool, if you have removed a requirement or a user story or a feature that was older than 1 month, could you please raise your hand? Something that was older than a month and it was in the backlog and you removed it out. Okay, keep your hands up. Older than 3 months. So you removed something that was 3 months or older. All right, older than 6 months. Older than a year. Something older than 2 years. You removed the story older than 3 years. You removed the story older than 5 years. You removed the story older than 7 years. Okay, we're at 7 here. Okay, so I've removed stories that were older than 5 years. Not older than that, but you know, around 5 years. Now imagine this. I'm John, the developer. Product owner comes to me and says, "Hey John, how long do you think that feature will take?" And I say, "Yeah, maybe 2 iterations, so 4 weeks." "Oh, that's great. Let's put it in the backlog." And we put it in the backlog. 5 years later, product manager comes to John and says, "Hey John, you said that feature would take 4 weeks. Where is it?" And of course, John has to reply, "Well, you never asked how long it would be in the queue." So think about this. If 80 to 90% of the time work is laying still and motionless in a queue, what's the value of an estimate? Because this is the reality. The reality is that 80 to 90% of the time work stands still. So if you say something takes 2 weeks, but you never say it's, you know, the average queue time in our project is 8 months, that 2 weeks, that estimate has no value. Because of course the wait time is orders of magnitude higher than the actual duration of the effort. Yet we plan without looking at the queue size. How many of you are tracking lead time in your projects?
What?
Lead time.
What is it?
Good question. So that means you're not tracking it. We can talk about lead time and cycle time later on. Okay, 2 people. 2 people are tracking lead time. Lead time is far more important for when you're going to deliver something than any effort or duration estimate. If you don't track your lead time, you have no clue when something is going to be done, period. I mean, of course, you know how long the work you're going to do now is going to take. That you can say, because you're working on it. But you can't say anything to the item that is in position 3 in the backlog, because you don't know the average queue time. If you don't know the average queue time, you have no clue when it's going to be done. So the next time somebody asks you, "When is feature X going to be done?" your reply should be, "I'm sorry, we don't know the queue time, the average queue time for features, so we actually have no clue when this is going to be done." If you do have the average time for queue, you should say, "Well, according to our data, the average time that feature will wait in the queue is whatever, like 5 weeks. And after that, assuming that the accidental complication has not exploded, i.e. John has not started to commit without compiling, then it might take 2 weeks." That is a valid statement. It's based on data. Okay, the duration of the actual work is still an estimate, but the queue time is far more important. There's a great video on YouTube about this. It's called Naked Planning. It's by Arlo Belshi. Brilliant, brilliant guy. Definitely worth following his blog posts. And he talks about what he calls naked planning. And what is naked planning? They basically had a list, you know, post-its on a flip chart, basically. They had a list of work to do. And then they had, for every position in the queue, they had the average delivery time. That was the lead time, right? So they knew the lead time for every position in the queue. So you could always go to a product manager and say, well, if you put it in this position, it takes X. If you put it in this position, it takes X. If you put it in this position, it takes X. This is also called the Disneyland average wait time, right? When you go to Disneyland or Legoland or whatever, if there's a big queue, you will see at different points in the queue, there will be a board saying from this point onwards, it's about 15 minutes, 20 minutes, whatever, right? That's the average wait time. That is much more important than any effort, cost, or duration estimate. But most people don't use it. So you can't succeed. The game is stacked up against you. All right, I'm going to go very quick through these slides because they just prove what I have said already, and you can see this on YouTube. So we can't be very good at estimation. And if we look at data from industry, there's no evidence that anyone, like no one, is good at estimates. I'll show you a few data points. This is Chaos report, 80% of projects late or failed, but this is from 2004, so you go like, that's too late. Okay, let's look at some newer data. 2011, average time overrun, 63%. This is very much in line with the data that I've collected in the companies that I've worked in, so I believe it, but of course some people do not really like the Chaos report, so we need to look at other data sources. All right, Gartner, Survey of Project Failure, 2012. Look at those failure rates, and by the way, failure means nothing delivered. It's not just late, nothing delivered. There's a lot of late projects in this lighter blue line here. But in the dark blue, which is failure, we have 28% for large projects and even 20% for small projects. That's 1 in 5. That's not very smart money. If you're going to bet in projects and they're going to fail at 20% rate, no one would do that, not with their own money. How about this? Journal of Defense Software Engineering. This is an article by Pert Charts, one of the gurus of estimation, and he writes, of the large systems that are completed, because there are large systems that are never completed. Of the large systems that are completed, about 66% experience schedule delays and cost overrun. That's 2/3. 2/3 of the projects in the Department of Defense in the US experience schedule delays and cost overruns. Now, of course, we have to say that these guys, the Department of Defense, they have the best project managers in the world. They've been trying to improve their track record from the 50s. Have you? So it's likely that they are better performing than you. Still, 66% delay and cost overrun. I'll just go to this one, which is, I think this is the kicker. This is McKinsey & Company with the University of Oxford. They looked at large-scale IT projects in 2012. 17% of these large-scale IT projects in 2012 went so badly that they can threaten the very existence of the company executing the projects. Let me translate this to the language of what I would use normally. It's like taking a mortgage on your house and betting all of the money on France winning the Euro Cup in 2016. It's not a very smart idea. What it means is that you bet, and when you bet, you die. Or when you lose, you die. That's not a very smart money, right? We don't want to do that. It doesn't make any sense. So believe the data, not the estimates. Forget estimation. If you do have to estimate for whatever reason, politics, internal policies, whatever, do the estimate, but then as Scarface would say, don't get high on your own supply. This is the worst mistake I see projects doing. They estimate, they put a lot of effort into the estimate, and then they believe in them. That's just stupid. There's no data to support the idea that estimates are reliably accurate. So you shouldn't believe the estimates, even when it's your own estimates. Hence, never get high on your own supply, right? So if you do have to use estimates, present the estimates, get the project approved, and then throw them away, right? There's this very, I don't know if this is really true, but it's a great story. There's this apocryphal story. I think Craig Larman tells this story in the, one of his first books. The Pert Chart. Pert Chart is a tool that is used by project managers, and it's basically a network tool that allows you to see the dependencies between tasks and what is the cumulative effect of delays in any of the tasks. All right, so here's what they did. They invented the Pert Charts when the Congress of the United States wanted to survey, control, govern a project in the Department of Defense. So this general, I can't remember his name anymore, he told his team, hey guys, let's make this, you know, very detailed plan with all kinds of numbers. Let's make sure it's printed by computer so that it looks sophisticated. Let's go into this room and then we'll put it on the wall. So they did that. They had the plan on the wall and it was all printed by computer. It was a Pert chart. Then they brought the congressmen in. They explained the project and so on. And you know, Congress was happy. You know, we've had oversight. This is working. We've done our jobs. They went away and the general told his team, now lock that door and don't let anyone in. Because he wasn't stupid enough to believe the plan. Because things would fail, things would change, surprises would happen, and what is more important is to react to those surprises. Right? That's like responding to change over following a plan. Does that sound familiar, by the way? Just checking. All right, so what's a good estimate? This is amazing. So these are three guys, PhDs in estimation, by the way. PhD in estimation means you've spent around 20 years trying to get better at estimates and doing math and science on it. And this is the best they can come up with. Look at this. A good estimate is an approach that should provide estimates that are within 25% of the actuals, 75% of the time. Now, there's a lot of numbers there, so let me try to translate this. It's like this. You have $100,000 burning in your pocket, and you want to get rid of them, right? You want to invest them to make some money, to make some returns on that 100K. So you come to me, and I'm a good investor, right? I'm a good investor. You come to me and say, hey, Vasco, we've heard you're a good investor, so we have 100,000. We would like to invest with you. And I say, yes, I am a good investor. I can even prove it. And I am guaranteeing to you that I will only lose $25,000 of those $100,000, and that's with a 75% chance. I could lose a lot more, but that's not likely. Would you like to invest with me? This is what we're telling the boards that approve our projects when we present an estimate. We're basically telling them, it's unlikely we will lose more than 25% of the money you're giving us. The only reason why we still do software projects is that software can easily return 10 to 100 times more than what you put into it. Because if that were not the case, we would not do software projects. That would be the craziest idea ever. Imagine if you had this with roads. You would give money to a road constructor, and 25% of the time the road wouldn't be there. 75% of the time that would be the case, and then in the rest of the time it might be that you would have holes all over the country and no road. It's crazy. But this is the kind of investments we are making when we make decisions based on estimates. And that's, by their own definition, what a good estimate is. They don't say what bad estimates are. So principle number 4, don't use estimates. Seek and use alternatives. So I'm going to skip these 2 next stories because otherwise I'm going to put you all to sleep. I see some of you already asleep. I'm going to go to this story here. So this is Sven. Sven runs a company in Germany. And they do software for third parties. So they actually have to give them a price tag, right? And the price tag they give those third parties has to be, let's say, acceptable, because otherwise they would never come back. They would sue him, etc., right? That's, you know, a case that many of us are, those of us that develop software for other companies. So what did Sven do? He came up with this brilliant approach. All right, so we have this data from all of these other projects we've done. Let's just categorize those, and then we'll see how much they actually cost. Not how much we think they cost, but what they actually cost when we did them. So they came up for every category of project. They had 10 categories of projects. For every category of projects, they came up with a price range. Okay, if this is, you know, if it's a new intranet, it will cost between whatever, 20,000 and 500,000. What makes the difference? Then we have the 10 characteristics we look at. What kind of technology? What's the size of the company? How many pages do they want us to implement in the first release, etc., etc., etc. So they had 10 different categories. And they looked at the data they had, and they came up with number of people in a range, cost in a range, and time in a range. So I had this table, and now every time a client comes in, they just ask him these 10 questions, right? If the RFQ comes in with those questions answered, perfect. They don't even need to call the customer. They'll just map it to the existing categories and give it a price, give it a timeline, and more or less know how many people they need for that project. Not based on estimates, but based on actual data. So what happens is that Sven can now give that to another person in the company that can do that mapping. He doesn't need to do that. He does not need to interrupt the projects of other clients. That would be interrupted if you had to get the developers into a room to estimate the project. And now he can give a price, duration, and number of people quotation in minutes without interrupting anyone.
So he's never getting completely new projects?
All of the projects have some similarity to the old projects. They could be completely new. It could be a development from scratch.
Yeah, but that's my point, right? So let's say that there's like a big chance for his company, a project so big that he have never done it. So
He would never do that.
Okay, so that
yeah, because the key thing is you should never do a big project that you have never done before. And the reason is this stat here.
Yeah, but that means actually that you should never do ever in the future a big project.
No,
If you've never done it
that's not
before,
what I said.
it's never the
That's
first-
not what I said.
Yeah, but that's how.
That's
okay.
how. That's what you heard because you don't want to listen to the solution. The solution is simple. If you get any big project, you break it in two. If the remaining two projects are still too big, you break those into 4, and so on and so forth. So actually, the problem is that every time you accept large projects, you're here.
Yeah, but what if this is a fresh company that you don't have experience in? You don't accept any projects, or you just...
You look at the data you have. If you have no data, you reduce the risk. How do you reduce the risk in a software project? If you have a 3-month delivery, you do 1-week deliveries up to the 3 months. That's it. Never, ever accept a large project. Now, why did the Agile community come up with DevOps and continuous delivery and so on? Because it reduces the risk of failure. And what is that? By the way, nothing new. Already in the 60s, I think it was IBM, if I remember correctly, I could look it up, developed a methodology called Clean Room. And that was actually an engineering methodology, but they also had a project management part to it. And what they did was very simple. They took any project that came in, and they divided it into 50 2% increments. So any project that comes in, you divide it into 50 deliverables. And we're talking about real big projects like, you know, aircraft carrier software, missile guidance software. We're not talking about like small, you know, web pages in a garage developed by 2 guys. We're talking about like really large amounts of software being developed for high-risk, mission-critical applications. And what they did is a very simple application of the principle of continuous delivery, which is You have a big project, that's 100%, and you divide that into 50 increments. What that gave them is that every time you deliver an increment, you now have data. So if you're a new company, you've never done those projects before, what you do is you divide anything that comes in into 50 increments, you deliver the first increment, and then you use that data to forecast, not the Polish weatherman forecast, but like the real forecast, the next 49 increments. When you have data from the first 2 increments, you have a better forecast. Data from the first 3 increments, a better forecast. And these guys were delivering software to production in aircraft carriers. So when we say, oh, we can't put it into production because, you know, our web server does not allow us to do releases every week. Well, there were guys in the 70s doing releases to aircraft carriers. 2% of the project.
Okay, it all sounds of course reasonable, and I'm a true believer of approach like that, that you base your price tags and everything on your past experience. It sounds reasonable, but the problem which I'm stating is that you have to have the other side cooperating, the client side cooperating, and the client side being keen to say, okay, I'm ready to have 2% increments, but usually, from my experience, is that the client says, okay, I want this system, I have this budget, right? We can negotiate the budget, of course, at the beginning, but at the end, I want the final price tag, because my boss also gave me this budget, right? So I can't tell my boss, we will see in 2 weeks what the price tag will be, right? And so
if I deliver every day, I can deliver anything I want, whatever budget I want, if I deliver every day. If I deliver once in the project, I'm screwed anyway. Doesn't matter how good I am. And I mean, just look at this. The larger the project, the larger the failure rate. And if you look at the data we have from even small projects, it's 1 in 5. So the question I have for you is, if the customer is not collaborating, would you risk the bankruptcy of your company to please the customer? Because that's the question you're asking. Am I going to risk going bankrupt so that I can keep the customer happy? And by the way, many companies do go bankrupt, especially small software development companies. Luckily, there's so much work in software development that they can easily find another job. But there are companies going bankrupt exactly because they want to please the customer.
okay, so just the answer is that you shouldn't do business with companies that want the big estimate at the end and the price tag. If they're not able to work on the increment.
So let me ask this question to the rest of the audience. Who of you would prefer to work on a monolithic, fixed price, fixed time, fixed budget project versus working on an agile, continuous delivery, always on time, continuous prioritization project? Which one would choose the first project? Which one would choose the second project? You got your answer.
Yeah, but the question can be reversed. If you are on the client side, which project would you prefer? The one in which you, from the beginning, know the final price?
But you don't know.
I know that I will pay probably as a client, right? But most of the clients want to know the final price. And that's the problem.
The client that wants to know the final price ahead will fail 1 out of 5 times. Yes, in the back.
The question is, why the client wants to know the price? They want to know the price because that's an investment. They invest the money, and they need to know whether they will have return from the investment. And they will not know the price, and they will hear that you want to know how much money we will spend on the project.
Okay.
They say that it's a high risk project. Yeah.
So this is profit. This is size of project. What this data is telling us is that this goes like this. Oops. This is infinite, right? Minus infinite. When you base a large project success on an estimate, you have no limit to the downside. But here's the kicker. You have a limited upside. Because this limited upside comes from the fixed scope. The best I can do, if this project succeeds 100%, is to generate a 2% increase in my sales. The worst I can do is that I can go bankrupt. Would you take this bet? If I came to you and said, hey, I can guarantee, if we are successful, I can guarantee a 10% increase on the profit. But I have no idea if we'll succeed, and if we don't succeed, you go bankrupt. Would you take that bet? So how about we do something different? We use something called value discovery. Do I have a red pen? Here. We do something called value discovery, also known as lean startup, no estimates, agile, and so on. And we go like this. We don't know the size of the project, but we do know we will definitely discover value at some point. So instead of saying, this is the profit we're going to make if we succeed, we say, we have no clue how much we're going to make. So let's say that we try first to go for 0.5% increase in the sales. Right? So we do some work based on that, and we are at this point, we've spent some money, and we go like, did we generate 0.5% increase in sales? It's an easy question to answer because the sales are already in, and you know whether you've made it or not. If you didn't, stop the investment. You've capped your downside, i.e. how much money you lose. You've limited it. But what if you, and I'll show you a case in a second, what if you, at this point, you actually found something that increased by 3% your sales? Or better, what if you found something that increased your sales by 30% at this point? What did we just do? We limited the downside and we unlimited the upside. Which kind of bet would you like to make? One that when you succeed you make enormous amounts of money but you never lose much. Or one that when you succeed you make a very limited amount of money but you could lose everything. Which bet would you take? And if you don't believe this is true, let's look at an example. A real example. Many of you will probably know this. This is Airbnb's growth from 2010 to 2011. You know how much they grew? 800%. How did they find that growth? So they went to New York. They wanted to, acquire new customers, and they didn't know why New York was not catching up. So they went to New York and they started knocking on doors and asking, hey, would you like to become our host? There's these advantages, and people come, and you can give them breakfast and charge a little bit more, and you can meet people from all over the world. And they got some new customers. But here's the thing. For every new customer they got, they also took professional photos. And they figured out that the entries in Airbnb with professional photos had a 30% higher booking rate. When was the last time your business discovered a 30% improvement in performance? I run a business. I can tell you that's a gem. If you find that, you invest a lot more into it. So they did. They started what Airbnb later called the professional photography program. They paid a photographer to come to your house and take pro photos so that you wouldn't put the crappy photos you had on the website. Why did they do that? To generate this kind of growth. That's what we are looking for. We want a way of developing software that makes the upside unlimited while limiting the downside. Now that sounds rational, but how do you do it? It's simple, continuous delivery and no estimates. We already know how to do it. Every single software team in the world could start doing that tomorrow if they wanted. But we don't do it. Why? Doesn't it sound obvious that this is a better choice? Why don't we do it?
First of all, the continuous delivery is not always possible.
It's always possible. It's not always desired.
It's not always possible, for example, with medical products where...
Oh yes, I can tell you a medical product story.
That would be great. I work in a medical company.
Okay. So there's a decision strategy for no estimates. There's many decision strategies. But one of the key things with no estimates is, okay, how do we make decisions without estimation? That's a question everybody asks. But there's one particular point, which is, or one particular decision strategy, which is do the legal requirements first. I was working with this medical company, and they had a 3-year project. Long project of introducing a new device into the market. Now, what happens is that in medical companies, you have to get FDA certified before you can start selling. Not before you can show, not before you can show the product, you have to be FDA certified. Not even selling. Like, you can't even talk about the product to doctors and hospitals before you are FDA certified. So I had this 3-year project. And it's the same industry all over the world. It's probably working with the same subcontractors and everything. So it's always 3-year projects for everyone, right? So what did they do? They said, okay, let's do the legal requirements first. And they did the legal requirements first. They did the delivery after 1 year. So they didn't do continuous delivery to FDA, but after 1 year, they had the FDA delivery. They got certified. And after that, they would change the product, of course, because they're still 2 years in the product development life cycle. But it's okay to recertify. That's perfectly okay. If you do some changes in some areas of the code, you can then recertify. That's perfectly fine. So what did they do? They started developing the product. They finished the first release. They got it certified, and they started selling it immediately. That's 2 years ahead of the product being available. So they were getting pre-orders for their product that no one else in the world could even start selling because they were the first ones in the market. For the next 2 years, they did changes and regular certifications. It's not continuous delivery in the sense of every day, but every few months they recertified the product. So they could always show the latest new features to the doctors and show progress. The doctors were, of course, excited because they could see something. The competitors could only say that we have, this kind of product in development, but they couldn't show anything because it's not allowed by law. So what happened? This particular company went to the market 2 years ahead of the competition. It's not continuous as in every day, but it's multiple releases before the final release, and every single one was able to be shown to clients.
Okay, we are doing it every half year, right? So it's by continuous delivery, I'm thinking, okay, I done some code, I commit, and then it goes to production. And in some companies, it's just not possible.
Well, it is possible. So let me tell you an example of Audi. Audi does software for cars. Now, no one would accept that an Audi would be changing the software every week or every 2 weeks. Or would they? Well, we now know they would. Tesla does that. They do over-the-air software updates to the cars. But Audi isn't able to do that. So how the hell can Audi do continuous delivery? So I had this friend working at Audi. He's an agile coach. And he was talking to the team, and the team was saying exactly what you said. But we can't deliver this to the software to the cars because the cars have to come to the shop, and an actual mechanic has to install the software interface to the central processing unit and change the software. And that takes years in the best case. All right, that's true. But wait a minute, don't you drive an Audi? Isn't your Audi outside in the parking lot? Why can't we put the software in your car? Continuous delivery. It's not all of the Audi cars in the world, but it's a population large enough to help them validate the software on a continual basis. And for those guys, that's continuous delivery. For a guy that runs a web server, continuous delivery might be 5-6 times a day, or like Google several thousand times a day, or Amazon another 1,000 times a day, or whatever. Different domains require a different approach. But in all of these stories, the common denominator is that they went from monolithic deliveries to very fast, smaller deliveries, including medical devices. So continuous delivery is possible. What is the hardest thing to do in continuous delivery is not the actual technical part. It's the content part. How do we convince the product owner to create vertical slices that can be delivered independently, no matter what else is in the backlog? How do we convince the developers that it's possible to deliver incrementally, that we don't need to spend 4 months developing an RFC before we show it to a customer. This happened to me. I was working with a team that was delivering a security product based on a network RFC. And they went to the product owner and said, look, this is a new product. We've never done this before. So we need 4 months before we can show you anything. 4 months. And 4 months is not that bad for many companies, but for that particular company, that was not a very good idea. So I went to the team and I asked, okay, guys, so what's going on? Why do we need 4 months? And they said, well, we have an RFC, and we can't really show anything until the whole RFC is implemented. Right? Makes perfect sense. Like, you can't implement half of an RFC client. It won't work. Or will it? So we actually looked at the RFC, and we said, okay, this is an RFC that has been there for a few years. Do we have servers for this RFC? Do we have like free, open source servers we could use? And they said, yeah, great, let's get one of those. All right, do we have a network packet tracer? What is it called now? Shark something, I can't remember. Wireshark, right? Do we have Wireshark? We do. Awesome. All right. So how long will it take you to generate code that sends the first packet of the first handshake of the RFC? We can do this in a few minutes. Great, let's do that. Let's put Wireshark on, get a real server on the network. Does it work? Yes. All right, great. How about the second packet? How long will it take for you to send the second packet of the RFC? Well, that's a bit more because we need to do some processing of the response of the server. But we have this library we've used in the past, so yeah, 2 hours. Okay, cool, let's do that. We did that, then 2 hours later we tested it. All right, we now have 2 steps of the 3-step handshake with the server. And we went on and on and on. It turns out that you can do continuous delivery on an RFC at the 2-hour cycle easily. So every 2 hours, a new delivery. Now, this can't go to the market, right? You can't sell this to a client. But you can prove that it works. You can do integration testing with a real server. And once you've developed the client, you can now use the client you've developed to develop your own server. How brilliant is that? You could use the same integration tests you used for the client to now develop the server. So this is just another example of how actually the hardest change for continuous delivery is not technological, it's not business, it's mindset. If we want to deliver very often, we can, but we have to do the homework. If we don't do the homework, it's never going to happen. If you can deliver every 2 days new functionality to the market, how important are estimates? Not very much. Because the only thing we need to now answer is what's the next functionality you want in the market, and in 2 days you'll have it, because every 2 days we deliver something new to the market. And if we're late, it's going to be in 4 days. So that's not too big of a problem. But when we go to the board, to the project management board, and we say it's only going to be ready in 6 months, of course they want to know how much it costs. Of course they want to know how many people are working on it. Of course, they want to know the exact date when you're ready so that the marketing team can be ready. All right. We've already covered a lot. By the way, I love this. We actually have planning cards for no estimates. Yeah. 1, TFB, too effing big, and NFC, no effing clue. Perfect. All right, there's a lot of stuff we could cover. I'll give you one more example. That's the last one. Then we'll do one more exercise, and then it's all fun. Because it hasn't been fun so far, right? All right, so what difference does a story point make? This is a story. Did I put my clicker somewhere? Here we go. This is a story from a guy at Microsoft, and they had a whole project. They actually did the whole backlog. They wrote down all of the stories, and they estimated all of the stories in 3 buckets, 1, 3, and 5. So they gave each story either 1 story point, 3 story points, or 5 story points. They estimated that, and after they had a few points of data, they looked at the story points they had delivered and how many story points they had to deliver, they did a projection and they said, this is going to release around the 20th of October 2014. This is a projection based on estimates. Story points are estimates. All right, cool. What if we change the scale? What if instead of 1, 3, 5, we have 1, 2, 3? And notice that 1, 2, 3 is not the same relative scale as 1, 3, 5. Totally different scale. What happens? Release date, 14th of October. 6 days difference. We just totally changed the scale. And the difference is 6 days. All right, what happens if we get rid of story points? Let's just count every story as 1. We've done the estimates, but let's ignore that. You know, Excel magic, find and replace. Release date, 29th of September. Conclusion, all of those dates were between 3 weeks between each other. 38 to 42 weeks were the durations of those 2 options. An error margin of 8%. When was the last time you did a project that is about 42 weeks long and you had an error in your estimate of 8%? It doesn't happen very often. Normally, we're talking about tens of percent. And by the way, the definition of a good estimate is 25% is okay. So just counting the number of stories has a difference of 8% to actually doing story point estimation. I was having an email chat with Bill Hanlon at Microsoft, and he says, at that point, I stopped thinking that estimation was important. But he did the experiment himself. He did not believe some crazy guy talking about no estimates. He said, let's investigate the claims. And this is what you guys should do. Take the data from your projects and actually do this. The same thing that Bill did. Just do the projection. Remove the story points. Just do the flow of value or throughput and then see when it's going to be done. Easy enough to do. And that actually takes us to the last principle, and you can see all of the other principles online. The only way you're going to be able to apply no estimates is if you start applying it. Don't try to change the project manager. Don't try to change the other team members. Don't try to change the project management approval board or the PMO. Don't do that. Just don't do that. It's not worth it. Do this yourselves. Take the data, and we can do it over beers at the bar. Definitely, it's easy. I have my Excel with me. We can do this. It's easy. So do this, and once you've done it, and once you finally believe that, hey, actually, this crazy idea actually works, then at that point, you will never believe estimates anymore. Not only that, you will stop giving estimates. You'll just say, product owner comes in the door and says, hey, John, when are these 20 features going to be done? And you'll reply, I'm sorry, you have no clue how many stories there are behind those 20 features, so how should I know when they're going to be done? If you want to know when they are going to be done, then let's create all of the stories for those features. Or I have a better idea. Why don't we just do continuous delivery? Every week, I'll deliver a new thing to you. Might not be a complete feature, but it's going to be a little bit of a feature. Then you see if that's enough. If that's enough, we go on to the next feature. Then you can decide when it's going to be done. Wouldn't that be great? And as a bonus, you get an Excel model you can give the product owner and say, oh, and by the way, if you come up with new features, it's easy. Put the number here, and then you get an immediate release date. And guess what? You don't need to email me. You can answer that question yourself. Wouldn't that be great? So that's a promise. Over beers, I'll tell you how to do that. How do you get the product owner to answer the question, when is this going to be done, on their own, without bothering you? If you're a product owner, without bothering them. All right, that's it. Thank you, guys. We obviously have one final exercise for the day, just ahead of the beers that are coming. And by the way, there's still bananas and grapes and apples and water and coffee over there. So you can take one of those or many and pair up, just like you did before, but change the pairs. and answer the question, why can't I use no estimates starting tomorrow? Why can't I use no estimates starting tomorrow? Please write the answers on a post-it and bring them here. Some lucky people will get those problems solved during beers. That's a promise. The reason why I wanted to do that is because I actually want to show you a video. Now, this is a first. This video has never been shown outside the No Estimates workshop. So you are privileged. But what I do want to do with this video is get somebody else to tell you what they've done to apply no estimates and how they changed an 18-month project into a 2-week project. Is that possible? Let's see. It gave you validation that you were on the right path, that you knew how to improve your craft, how to improve the industry and the work that you did. It could be about, estimation, insights or something, but it could also be just about something that really proved that you, Clinton, had found a better way and you were on the right path.
Sure. Well, one of the last games I worked on, it was based on the movie Bourne Conspiracy. I don't know if you're familiar with the Bourne movies, but we had using Scrum, had a prioritized product backlog we were developing, and because of some delay with some middleware that we had to delay the release of the game by 3 months. Now, along the way, we had, if you're familiar with the movie, there's usually a car racing scene that lasts about 15 minutes. And we had dropped that because, it wasn't part of the core experience of the game. We would have liked to, but, it was low on the priority list. So when we got this 3 extra months, our publisher came back and said, well, can we do a racing scene? That's just 15, 20 minutes. We don't want to spend we can't spend a lot of time. We only have 3 months. What can you do? Now, I've done a few racing games in my past. And so I said, well, we could take a look at it. Now, it's probably a 50% chance we'll succeed or 50% chance we'll fail. 3 months is a very short time when in the past I've taken 18 months to make a city racing game with police chasing you and traffic and things like that. But we'll give it a try. We'll pull a team together. I'll be the product owner, and we'll try it out. So the very first challenge is that, well, in addition to making a city and having a car drive around, you have to have the police chase you around and have to do it in a way where they're avoiding traffic in this complex city. They're finding you. They're seeking you out. And it's a very complex problem. Now, I had some programmers say, well, we could do this. We can do pathfinding, artificial intelligence, and all these things. And I said, hey, listen, there's no way we can do this in 3 months. It took 2 people 2 years or a year and a half to do this in the past and still had many problems and challenges. So what else can we do? So we took a step back and said, well, why are we thinking of the solution? Really, the problem is that we want the player to think that they're being chased by police, like Jason Bourne is in the movies. And being chased and being caught is really dependent on how fast you're driving through this very complex city. So when we thought about it like that, somebody said, well, why don't we just do this? We have a 2-week sprint, 2-week iteration. Let's just, if you're driving too slow, we'll just monitor the average speed of the Mini Cooper driving through Paris. And if you're driving too slow, well, what we'll do is we'll flash some blue and red lights off of the surrounding building as if there's a police car behind you. And if you keep driving slow, we'll play a siren sound that gets louder and louder. If you continue to drive slow, well, that means you're caught. Then we'll just play a little video of you being arrested and handcuffed and taken away. And I said, okay, let's try that. And they got it done in less than 2 weeks. I think it was just a matter of days they had something running. And since this was late in the game as well, we could test that with focus test players. And most of them were fooled. They thought they were being chased by the police, after 3 or 4 days of work. Now, the people that weren't fooled were looking in the rearview mirror of the car. And they said, well, I hear police and I see the flashing lights, but when I look in my rearview mirror, I don't see police. And so guess what our solution was? to remove the rear view mirror. So 2 days later, we tested again without a rear view mirror, and not everyone thought they were being chased by police. So within 2 weeks, we had a solution of being chased by the police, and we just continued through the next 2.5 months of embellishing it so that, well, if you instead of playing the movie, what we'll do is we'll kind of teleport 2 police cars right behind you that didn't have to maneuver through the city, didn't have to have artificial intelligence, but just came up on either side of your car and rammed it and stopped it. And so it was just more exciting that way. And that just turned on a big light bulb over my head.
How about that? 18-month project done in 2 weeks. Real project. Some of you maybe even played the game. That was one of the guys developing the game. And they turned an 18-month project into a 2-week project. If they had estimated that project, it would probably have taken more than a year. And actually, he says that in the video, to develop the exact same thing. Of course, because, you know, if you have a year, why don't you develop a complicated artificial intelligence model to have the cars drive around in the city? And you do random or statistically random models for traffic to move around so that you make it more interesting and always different, and so on and so on and so on and so on. But what they did, one of the things they did, which I think was brilliant, is that they redefined the problem. And this is the key thing. In software, what takes time is not the solution. What takes time is solving the wrong problem. If you can redefine the problem to be easier to solve, then you can get the same value, not the same solution, but the same value delivered much faster. So I wanted to show this video because it's not just me who is thinking about these things, and there are actually people all over the industry thinking about how can we get rid of estimates altogether. But okay, let's look at the reasons why you believe that it cannot be done tomorrow. Okay, first reason was it's Saturday. Well, that's not a reason. You have a laptop, you have Excel, you can do it tomorrow. That's fine. I don't know what to do instead. So that's something we can answer over beer. I have Excel, I have a laptop, I can show. It's easy. Right. Then audit will check us in at half term. Okay. So I'm a project manager by training. I actually did the project management certification. I studied project management for a long time. And for a few years, I actually thought I was a good project manager. Now I know I was lucky. But, you know, back then I thought I was good. Here's the thing. What audit wants to make sure is that you did what you promised. The problem is the market out there doesn't care what you promised. They want value delivered. So we have a fundamental problem in the way we govern software delivery. We govern software delivery just like if we were managing farming work. Let me explain that with a metaphor. When we lived off the farm, if we spent 5 hours planting potatoes, we would get about 5 hours worth of potatoes when the harvest came. If we worked 10 hours planting potatoes, we would get about double the amount of potatoes come harvest. Here's the thing with software. In software, you can work the whole week and deliver something, and then on Monday you come in, you deliver something, and you break everything that was delivered the last week. Time is not correlated with value. Effort is not correlated with value. And the problem with audits, and I know this is a real problem because I used to audit projects, by the way. I was very mean to people that were not on time. I was very mean to people who were not doing the tasks they promised they would do. Of course, now I know that was stupid, but back then I thought that was my job. But what audit doesn't check is how much value did you deliver. Only you can check that. I mean, you and the business owner, right? If we transform our projects to be around value delivery instead of task completion, we are more guaranteed to be successful. Also, we don't need estimates, so that's an advantage. So those of you that work with audits, what I would advise you to do is collaborate with the auditors all throughout the project so that they know exactly what you're doing. Because the amazing thing happens when you actually know someone, you start being invested in their well-being. So if you talk to the auditor, you know, every week or every 2 weeks, and you bring them in and you show, hey, here's what we're doing, here's how we're following progress, here's the problems we've encountered, here's how we've solved them, the auditor will actually start to like you. They might even be collaborative, and they might say, hey, I thought you were trying that no estimates thing. How is that going? Small trick. It doesn't change anything except the relationship you have with the auditor, right? So if the audit is a problem, then bring them in. Make them part of the change, which then leads us to this. It's hard to force other people to change. Brilliant. Absolutely true. So don't. Like, don't even try to change other people. You can use no estimates tomorrow with the data you already have without asking any permission from anyone. You can do that. And when you figure out that the project is 5 months late, even though everybody's thinking that the project is on time, then bring that up. And by the way, you will. You will find the project is late, because that's the most stable state for projects, is to be late. Also, the first day they're late, it's very hard to recover. How do you get a project to be 100 days late? 1 day at a time. And it's only on the 100th day that you figure out, oh, we are 100 days late. Can't recover anymore. I need to know how many stories I can take per sprint. This is a valid point, right? Because you're actually talking to people that expect you to know that. So the solution to that is fairly simple. You look at what you delivered last sprint. And you say, last sprint we delivered 5 stories. Next sprint, how many stories will you deliver? 5. It's called yesterday's weather. And in some countries, maybe not in Poland, that's actually better predictor than the forecast of the weatherman. Think about that.
Actually, the forecast is using this very often.
Yeah. So this is the thing. They did a study in the US. They studied many different televisions and their weather people. And some of those are actually meteorologists, so they are not just presenters. So they studied how often they were right regarding rain. So they were predicting rain, right? They checked how often they were right. Turns out that weather people are right about 50% of the time. It's like throwing a coin. It's just rain, right? It's a single event. It either happens or it doesn't happen. So you throw a coin, you're as good as the weatherman. But get this. If you had used yesterday's rain data to predict tomorrow's rain data, you would have been right 60% of the time. So actually this yesterday's weather is a great predictor of throughput. So if you need to know how many stories are we going to deliver next sprint, the answer is the same as last sprint. And you'll be amazed at how often this is right. Estimating without strong commitment helps us identify obstacles. So there's actually 2 statements here. First of all, the first statement is that it's possible to estimate without strong commitment. Unfortunately, it's not you who gets to commit. It's the other people that commit you. So if I go to somebody and say, hey, this will take about 2 weeks to deliver, then 2 weeks later, I don't deliver. You come to me and said, you promised 2 weeks. I didn't promise 2 weeks. I had no clue how long it would take. I was sick. Doesn't matter. Because commitment is always in the ear of the person who hears the estimate. It's never you that commits. It's the other person that commits you. Right? Okay, but that's the first step. Second, estimating helps us identify obstacles. This is true. Absolutely true. Here's another thing that helps you identify obstacles. Smaller stories. So why don't we make smaller stories? Because smaller stories have a much bigger benefit than identifying obstacles. Smaller stories give you options. Let me give you an example. If you have a story and you start developing it, now you need to deliver that story. If you break that story down into 2, you can now deliver 1 story without delivering the second. That's an option. You might still deliver the second, but you don't need to. in the process of slicing stories down, we identify obstacles without committing future decisions. Have you guys heard, I bet some of you have heard of commit as late as possible, or delay commitment, right? That's a Lean principle, always delay commitment. That's what slicing helps us do. Estimation is the opposite. Estimation brings the commitment to the point of estimation. Slicing delays the commitment to the point when you start working on the second story of the one that you divided into two. Much better, still helps identify obstacles. So why wouldn't we use the slicing heuristic instead of estimation? ROI and prioritization. This is true. It's absolutely true that if you have a cost estimate, you can use the estimate to do a ROI calculation and therefore prioritize. Here's the problem. If you estimate, you're not actually limiting the cost. Your cost is unlimited. And we have a lot of examples. For example, Accenture in the early 2000s had to drop out of a project with the NHS in the UK, and they paid £1 billion to get out of that project. That's a pretty expensive error of estimation. The problem with ROI calculations based on estimates is that they are fake. And they might be accurate for 90% of the cases, but the other 10% can kill you. Not a good idea. So how can you calculate ROI without estimating? The answer is simple. You budget. You say, we believe we can get X value out of this feature, so we're going to spend this amount and only this amount, and if the feature isn't ready, we drop it. Period. Now you have your ROI. The worst that can happen is that you lose that investment. Unlike if you estimate, the worst that can happen is that you lose a lot more than you thought you were going to invest. So it's safer to use no estimates for ROI than it is to use estimation. It's safer to use no estimates than estimation. Don't have user stories of similar size. Actually, in the book, there's a chapter where we talk about the impact of sizing on the no estimates approach. It really doesn't matter what the size of the stories is. Over time, your throughput is indicative of the real size of the stories. So you can use data to actually know the average size of all of the stories you have in the backlog. You don't actually need to know the size. You just need to know the throughput. The throughput already tells you what the average size is. So you don't need to have stories of similar size to do no estimates. You just need to count the stories. That's it. I think we pretty much did. Okay, there's one here. Steering committee want to know how much it costs. That doesn't work. We've seen data for that. We have two big stories, bigger than 40 points. Yeah, that's a problem, definitely. You can slice them. But in the end, you can still count the delivery rate, even if they are big stories. And then the one here, which I really liked, it says, sorry guys, I'm not using estimates at all. So, so that was brilliant. All right, so that was what we had there. I've tackled most of those, and now we have those on video. You can call me up on it. All right, and now I think we need to open up for questions. Is that the game plan?
Yep.
All right.
First question.
What's the principle 11?
What's the 11th principle? You said there's one more.
What is the 11th?
So I used to live in Germany, and I fly a lot. So I had to go to a client, and for that I had to take the flight. And I was right around Stuttgart somewhere, and I had to take the 8 and then the A5 or A6 all the way to Frankfurt Airport. And if you know about Germany, you know that highways are very fast. You can drive as fast as you want, or at least that's the car permits. So it's not that critical to have an average speed or whatever. You know that it takes about 2 hours, but it's 196 kilometers. I mean, if you drive at 200 an hour, you'll be there in an hour. So it's easy. Like, you can manage your delivery time, i.e. your arrival time, with the speed of the car. So I was pretty confident I'm going to make it on time. The flight was at 8 a.m., so I had plenty of time. I started driving at 5 a.m. and I took it easy, stopped for coffee in the middle, and then this happened. Because you know that in Germany they have this thing called the Heisenberg Autobahn. It's simultaneously the fastest and the slowest road in the world, right? So we had Stau, and I put the radio on and said, Stau is normal, it's, 6:30 in the morning, everybody's driving, whatever, this will go over. I put the radio on, and then somebody says, well, there's a truck in the highway that has turned on its side and is stopping all the traffic because it covers the whole highway. And I said, oh shit, I just missed my flight. What happened? In that story, what just happened? I had one chance to make the flight, be on time. And I had one surprise that changed my plan. The problem with that surprise is that it was big enough to invalidate the whole plan. But because I only had one delivery, that was enough to make me lose the flight. And this is true for most projects. Most projects are designed to fail. Because one big surprise is enough to kill the project's on time, on budget record. So principle number 11 is projects are the wrong way to reliably deliver software. What we should be doing instead, and we've talked about that at length already today, is continuous delivery. Always be ready to deliver. If the highways in Germany had exits every 100 meters, it wouldn't be a problem. But they don't. They only have exits every, 5, 10 kilometers. And if there's a truck between you and the next exit, there's nothing you can do. You're trapped. Not a very good idea if you want to succeed. So that's the 11th principle. No projects. Ask me how. Not now. All right. Questions? Sure.
Hi. Firstly, thank you for a really good talk. You made a lot of good, strong points. I just want to clarify one thing. Do I assume correctly that no estimates doesn't go well with Scrum, for example? Because in Scrum, you said that how to do Scrum with no estimates, you just take as many stories as you have done in the previous sprint, but the Scrum assumes that you should deliver them, right? So that's already a commitment, and we shouldn't commit, right? So I assume that it doesn't go well, or we just change the rules of Scrum too.
There's two very bad ideas in Scrum. One they've already fixed. The second they've tried to fix, but it hasn't yet. So the first bad idea with Scrum is not having retrospectives. Crazy idea. Today, you would go into an agile team and say, hey guys, you don't need retrospectives. Would you? But the original Scrum did not have retrospectives. So they changed that. So now the official Scrum has retrospectives. Here's another problem. Scrum asks you to commit. By the way, they don't anymore. They've replaced that with a forecast. Literally, that's the word they use in the new Scrum guide. So they don't ask for commitment anymore, they ask for a forecast. But there's still a lot of people out there believing that Scrum asks you to commit. Unfortunately, committing to a number of stories in the sprint is like me committing to arriving on time to the airplane in that story we just saw in the principle number 11. It doesn't depend on me. Why would I commit to something that is not dependent on me? And we've talked about different examples already today. TFS goes down, you can't work for 3 days. What you're going to do? John keeps committing without compiling. We need to fix his shit. What you're going to do? The product owner comes up with great ideas that require us to spend 5 days estimating stories we might never work on. What you're going to do? Commitment assumes that you own the process of delivering. That means we have to go to beers. The problem, however, is that reality doesn't care what you commit to. So I would say, if you're doing Scrum, don't commit. Use the velocity from the previous sprint, or even better, that's what I use. Use an average of the velocity of the last X sprints. And I can tell you what X means in practice over beers. So that's a much better option, right? Because it's not about what I want to deliver, it's what the circumstances around me allow me to deliver. And we need to figure out a way to know what that is without depending on, luck, which is what happens. DFS is down. Oh, unlucky. No, it's not unlucky. It's entirely predictable. DFS is always down, or at least regularly, right? So that's the thing. It's not incompatible with Scrum. Commitment is incompatible with Agile. But that's another story.